Failure mode and effect analysis. What is the FMEA or failure mode effect analysis? In a safety engineering and reliability engineering, a failure mode and effect analysis or FMEA is a systematic analysis of the system which will tabulate failure mode of equipment and their effect on a system or plan. Typically, the failure mode describes how equipment fails such as the open, close, on, off, or leakage. The objective of FMEA in the safety engineering is to identify the potential design and process failure mode before they occur and to minimize the risk of the failure. Especially the FMEA is to identify the equipment or subsystem, mode or operation and the equipment. Identify the potential failure mode and their cause. Evaluate the effect on the system of each failure mode. Identify measures for eliminating or reducing the risk associated with each failure mode. Provide information to operator and maintenance team to let them understand the capability and limitation of the system to achieve best performance. Human operation errors are usually not examined directly to the FMEA. It means human operator error will not consider as the failure mode, but the effect of the human error are usually indicated by an equipment failure mode. When is an FMEA carried out in engineering life? The main use of the FMEA is engineering life is a tool used during the identification potential failure of the equipment. So, the FMEA study is always mandatory required during the safety review in detail engineering stage for a new plan, modification, and expansion of existing routine operation and during incident investigation. FMEA Workflow. The following logical steps should be followed when performing as FMEA in safety manner. First one, define the scope of work and then define ground rule and assumption. Construct the system block diagram. Select the unit that we want to study and then identify the failure mode. Identify cause of failure. Analysis failure effects. Identify the corrective action, preventive measure, or existing safeguard. Then, we determine the severity, occurrence, and detection. And then determine the risk priority number or RPN. And the last one, determine the recommendation if you have. Benefit and limit of FMEA. The FMEA process is widely applicable in variety of settings beyond the product design, manufacturing process, or processing process. The most common type of FMEA are the system FMEA, design FMEA, and the process FMEA. FMEA or failure mode and effect analysis in engineering design can be extended to criticality analysis as FMECA or failure mode effect and critical analysis, or FMEDA or failure mode effect and diagnostic analysis. So, FMEA can further to be developed by determination of the failure probability, failure faulty analysis, inventory analysis, and LAM or reliability, availability, and maintainability. Since the FMEA is performed based on known failure mode, so FMEA technique can be applied to review the control hazards and probability analysis or HAZOP. FMEA Worksheet. For the typical FMEA worksheets, the columns are identified by following. First one, item. The name of the item or system function being analyzed for failure mode and effect. Then function, statement of the function performed by the hardware item. Failure mode, the predictable failure mode for each system level analysis by identifying failure cause. The most probability cause associated with the assumed failure mode will be identified and described in a Failure mode may have more than one cause. Failure effect. The consequence of is assumed failure mode on item operation, function, or status. The failure under consideration may affect several system level component, subsystem, or system. Prevention, corrective action. Existing measures taken to be prevent or mitigate the effect. Severity. The consequence of the failure should it occur. Occurrence. The probability or frequency of failure occurring. Detection. The probability of the failure being detected before the impact of the effect is realized. Risk priority number or RPN. By multiplying the ranking of the three factors above, it means the multiplying of severity, occurrence, and detection. 2. Prioritizing the risks. Recommendation. The task of FMEA team to reduce or eliminate the risks associated with the potential cause of failure. Example FMEA question. FMEA of failure mode and effect analysis or FMECA failure mode and effect criticality analysis is a methodology study of component failure. For each component, the review team will be asked the question: how could this component fail? How does this fail affect the system? The example failure mode of the component such as for battery, the failure mode should be decreased output, short, or open circuit. For belt component, failure mode should be excessive wear or broken. The component is a blower. Failure mode should be bearing failure, switch failure, brake erosion, out of balance, short circuit. If we want to compare FMEA and HAZOP, in the safety engineering review, the FMEA is frequently quantitative, but it is also often used qualitative as a hazard analysis technique. It may be used instead of the HAZOP in certain cases, and it is more equipment oriented. The compare between FMEA and HAZOP is preliminarily shown at below table. For the model, FMEA can do it both between qualitative and quantitative. HAZOP, qualitative method. Systematic, both of them are systematic. For the key study, FMEA, we have to know about the fail mode. For HAZOP, we use deviation. It means we use a combination between the parameter and the driver. Skill, FMEA require high skill more than HAZOP. Flexible, both of them have the more flexible in the study. So that is the FMEA. Thank you for watching my video and let's see in next video. Bye bye.